In this video, we're going to use a sample correlation coefficient to test the correlation between two pieces of data. It says the researcher collects the following random sample of data for the time students spend on the phone against the time doing homework. So we've got a table here, the hours on the phone, these are the hours spent on the phone, and these are the hours doing homework. So the researcher believes that those who spend time on their phone are not spending time on their homework and vice versa. Very current problem these days. Carry out a suitable hypothesis test using a 5% significance level. For these data, the critical values for n is equal to 8, because we've got n pieces of data here, are 0.6215 if the test is going to be one-tailed, and 0.7067 if the test is two-tailed. Now, a little bit about what the difference between R and this thing called rho. So note the correlation coefficient, R, summarizes the strength of the linear relationship in samples only. If we want to draw conclusions about the whole population, so to say this is a sample drawn from more data and not just the samples, we have to use the correlation coefficient of the population, which is denoted by rho, R-O-W, the Greek letter. R is called the product moment correlation coefficient. Okay, so carrying on now. If researcher thinks that the student who spend time on their phone are not spending time on their homework, then we are looking for some sort of negative correlation. And this will have an effect on the test. So the first thing is to state the null and the alternate hypothesis. So basically what we're thinking here, if we spend more time on our phone, we're going to spend less time doing our homework. Or if we're doing more time on our homework, we're spending less time on our phone. So if we bake H0, the null hypothesis is that the correlation coefficient rho for the population is 0, i.e. there's no correlation between the time on the phone and doing homework, and the H1 is that rho is less than 0, there is a negative correlation, i.e. more time spent on their homework, the less time spent on their phone, and vice versa. This is called a negative correlation between the time on the phone and doing homework. State the type of test. Because we're looking for a definite decrease, then the test is one-tailed, definite decrease. Okay, state the critical values, or critical value in this case. The critical value for n is equal to 8 one-tailed is 0.6215 at 5% level. This is given in the question. We will have to use, because we're looking for a negative correlation, minus 0.6215 as we're using the lower tail. Sorry, as we're looking for a negative correlation might sound better. Right, now, you can actually get these results from tables, although I think possibly the possible values will be given to you in a question. If you look at a set of tables, it used to look like this. So we want one-tailed, looking for n is equal to 8. The one-tailed will be the one at the top here, 5%, which is 0.6215. If we're looking for two-tailed, for 8, it would be this one here. Okay, so this is the one we need for our tests. The tables are not given in the exam, so I'm assuming that you will be given possible values to use. Right, we're now going to calculate the test statistic. Now this can actually be done very easily on the calculator, but it's a good idea that you have some idea on how this is actually done. So using this big table here, so we've got our x values here, 12, 5, 7, etc., and our y values here going down. And what we need to do is, first of all, work out is the mean for each piece of data. So the x bar is the sum of x divided by n. The sum of this is 64 if you add all these up. So 64 divided by 8, because there are 8 altogether, gives me 8. And then same for y. If you add all these up, you're going to get 88 divided by 8. That gives me 11. And now we work out how far each thing is away from me. So we're going to work out how far 12 is away from the mean. So 12 minus 8 is 4, minus 3, 7 minus 8, minus 1, etc. We work all those out. Okay. And then we have to square each of them because some of them are negative and positive. So squaring them, 16, 9, 1, 36, 16, 25, 4, and 9, then we will need to sum that column, which gives me 116. Same here, we work out how far each y value is away from 11. So minus 5, 3, 1, 2, 4, minus 3, 0, minus 2. And we'll square each of those, 25, 1, 4, 16, 9, 0, and 4. We'll sum that column, we get 68. To work out this column, we will need this one multiplied by this one. So 4 times minus 5 gives me minus 20. Minus 3 times 3 gives me minus 9, etc. Okay, and then one of them will be 0 because we've got 0 times 2. We sum that column, we're going to get minus 79. Now the product moment correlation coefficient R is the sum of x minus x bar times y minus y bar divided by the square root of x minus x bar squared times the sum of y minus y bar squared. So we need to put each thing rightly. So the first thing is going to be minus 79 because this is minus 79. The square root of 116 times 68, so make sure you pick the right ones. Okay, and if you work that out, you get minus 0.88949, which gives you minus 0.8895. Now, like I said, it can be done using the GDC. Now, using a TI calculator, but most other calculators will do the same thing for you. So going to the TI, I've already put the data in. And so in a spreadsheet, I've already put in the phone and the homework hours already in. Make sure you put them in correctly. So if you go press menu now and go to number 4, statistics, stat calculations and 2 variable statistics, and set the X list to be phone, and the Y list to be homework, if you've labelled them. If not, just leave them as A and C, and leave that as C. Press OK. It might overwrite some data, but we've already done. Okay, so here we get a lot of other statistics. So we get the means that we calculate, mean of X. You can get standard deviations as well. Number of variables, the mean of Y, which is 11, which we've already got. But obviously the one we're interested in is right down here, is the value of R. You can see here we've got exactly the same values we just calculated. So in an exam, this is what you would be expected to do, is to use the calculator to come up with this value. But it's a good idea to know how it works one time only. Okay, so state the conclusion. So as minus 0.8895 is less than minus 0.6215, we reject 80 and say there is significant evidence to support the researchers' conjecture. Okay, you can see this is closer to minus 1 than the critical value. Okay, so therefore we're going to reject. It's going to be outside the region. We should just perhaps note at this stage, although there is a high level of linear correlation, it does not mean that time on the phone causes time on the homework, vice versa. Right, could be other things which have to come into play. It could be such as parental control or amount of free time available. Does the student actually have to do some work after school, like paid work? There could be lots of other things that influence it. So you shouldn't just assume that one thing causes the other. Correlation does not imply causation. It's a famous saying. Okay, so it's been a video to show you how to test for the correlation coefficient, the test with using a hypothesis test. I hope you've understood. Sorry for the long video, but thank you very much for watching.